In this video, we're going to talk about dependent versus independent outcomes. We've already talked about independent outcomes, even though we didn't call it that. We talked about that in our previous video where we looked at the penny, nickel, and dime, and we made the tree diagram. These outcomes don't depend on each other. So once I flip the penny, I still have the same chance when I'm flipping the nickel and then flipping the dime. I'm not removing any possibilities from my outcomes, so they are independent events. Likewise, in this problem, where I am asked how many three-letter security codes can be made from the letters A, B, and C, I am not making the first selection depend on the second one, depend on the third one. I could draw a tree diagram for this, but instead I just made a list. I made a list of all of the possibilities of using letters A, B, and C. And we could use multiplication like we did in our previous example. So for each spot, basically, in my three-letter code, here's my three-letter code. For the first spot, I have three choices, A, B, or C. For the second spot, I have three choices, A, B, or C. And for the third spot, I have three choices, A, B, and C. So I'm just going to multiply all those together, and 3 times 3 times 3 gives me 27 possibilities. And again, you can count them all out in my list. I did it before I put on the video, so you wouldn't have to watch me write out all the possibilities. It's a lot of possibilities, right? Because our letter choice is not dependent, and we can reuse some of our letters. Now, this isn't always the case when we are talking about outcomes. Sometimes the second choice is dependent on the first choice, and the third choice is dependent on the other two choices. Let me give you an example. So here, how many three-letter security codes can be made from the letters A, B, and C? Same as our first problem, but without using a letter twice. And there's the dependent part, right? So for example, I'm making three-letter security codes. If my first letter is A, I can't use A again in my security code. If my second letter is B, I can't use B again. So my third choice has to be C. All right. So again, here, I'm just going to list out all my possibilities. So for my second possibility, if I use A, I can't use A again. So, and I've already used B in my first example. So I'm going to use C and then B. And those are my only two choices with A as a first letter. See how this is limiting my choices. How about if I select B as my first letter? Well, then I can choose A, or I can choose C as my second letter. And then for my third letter, if I chose A for my second letter, the only choice I have left is C. And if I choose C as my second letter, the only choice I have left is A. All right, so hopefully you're catching on. But what if I chose C for my first letter? Well, I could choose A, or I could choose B. And if I chose A, then the only possibility I have is B. If I chose B, the only possibility I have is A. So we have a lot fewer choices. Now, how does this look for our multiplication? Let's think about this. So again, we have we're choosing three-letter code. For our first letter, We could choose A, B, or C. So we have 3 choices. For our second letter, depending on if we chose A, B, or C, we could choose 2 of the other. We've eliminated 1 letter. So let's say we chose A. We've eliminated A. So we only have 2 choices left. If we choose then for our third letter, we've used 2 of our letters. We only have 1 choice left. And we're going to multiply these. And as we can see, we get, instead of 27, we only have 6 choices. So you can see how dependent outcomes are impacted. We have a lot fewer choices when our second choice is dependent on our first, or when our third choice is dependent on the 2 in front of them. So the multiplication is different because we are eliminating outcome options in a dependent I can't speak and write at the same time in dependent outcomes.